name's Mark, and I'm a CNC newbie, basically, total novice, and I'm planning to build a CNC plasma table. After watching some of Keith Fenner's videos over on his YouTube channel and watching him use the plasma cam, I thought it'd be an awesome tool to have in my little workshop. And I've been inspired by John from NYC CNC with his use of Arduino boards and garble shields and so forth. As I said at the start, I'm a total newbie, total novice with CNC. My background's web design, so I basically know a little bit about computers and some computer programming, but when it comes to CNC, it's a brand new topic for me. Electronics, again, brand new sort of topic. I wanted to build this cheap DIY CNC plasma more for the fact of the fun of building projects, because I like to build things. But also, I got a quote to do a house sign for our house. We've just built a new house, and it was like 450 Australian dollars for a 300 by 250 mil house sign. I'm thinking surely they would be cheaper, or there'd be cheaper options, but unfortunately no. So I thought, well, why not? Maybe I could build this, have fun building a project, be able to do my house sign. Mind you, I'll be putting more money into it than paying for the house sign, but I'd also be able to use it for future projects, working out in the shed. I'd also like to do some privacy screens, plasma cut privacy screens and so forth. Now the table I'm looking to build is 1200 mil by 1200 mil, which should give me enough room to start with, and there might be plans to extend it later on down the track. So I wanted to make this series so that I could, one, document my way through the project and help those other people that are wanting to do something similar, because you go and have a look on YouTube at the moment and there's certain videos that are great, like as I said, John over at NYC CNC is really good. I've learned a lot from him, but there's no real tutorials, or there's no real job builds from start of the project all the way through to getting the machine up and running. It's going to be a big commitment. I know a lot of people start out to do it, so I'm going to endeavour to do it. I will try and get the videos out as frequently as I can as the build progresses. I do have a young family. I've got basically 3 children under 2, a little boy who's about to turn 2 in May, and I've got 6-month-old twin girls, so time can be a little bit challenging to juggle, so I'm going to try and fit these in as best I can. Most of the equipment that I've purchased can be purchased through eBay. There's no real sort of specialty stores, and it's all locally, but I'm trying to do as much as I can here in Australia. The US has a big marketplace where you can get CNC components and electronics and so forth, and here in Australia it's quite challenging. There are places that do it, but the prices are just outrageous. For example, I was looking for some V-groove, 90-degree V-groove bearings for my to create the linear motion for the gantry, and they're talking like, for a size 2, they're talking like $60 for one bearing. It's outrageous. So I'm going to try and do this as cheaply as I can, and I know there'll be people out there, and it's like anything, you get what you pay for. Again, I really want to do this this project more for me. We'll have a look to see at the end of the project what the quality and what the tolerances of the machine's like. I guess that'll be all up to my build standards and my workmanship. But yeah, the idea is to build a CNC machine, CNC plasma machine, to cut out a house sign for our house, and to do other odd jobs around here. So stick with me, and hopefully we'll be able to put out some videos and help anyone else that wants to start a project like this. Build this machine. I decided to sort of start around, well, the first place I started was I bought some plans. I went online and I had a search around for some DIY plans for a plasma table. The first set of plans I found that I really liked were a set of precision plasma plans. Bought them on eBay. I think they cost me about $40 for the plans, and you get a complete build instruction sheet, which shows starts with the finished product, and then it runs through all the components that you need to make for your machine. So your carriage plates for your gantry, motor mount plates, torch holders, etc., Z access plate, outer Z channel plates, your rails. Now the linear motion system they use on this is using a V-bearing system, where they use V rails, which in the plans are 90 degree. I'll get into that a little bit more later on what I've just made some slight changes to this, but I recommend going out and buying having a look and trying to get a good set of plans, and a complete set of plans. This one has a build of materials listing. It shows you step by step how to put it all together as well. Okay, so these are a few of the components I've got so far, and I'll run through each component as individuals and talk about each of them. So we have an Arduino Uno board. I have a CNC Shield version 3, I think they're 8255 stepper drivers that actually attach into the CNC Shield. I've got 425 ounce-inch stepper motors. I've got 4 of these. The plans recommended that you use a motor of at least 270 ounce inches. This is 425. The reason I went 425 is it's a 2.8 amp draw per motor. The board only supports 2.5 with recommended heat sinks on the drivers, like I've got. So when you run them at 2.5 amps instead of 2.8, it's about a 10% difference, and it leaves me something like 310 ounce inches or something, which is still above what I need. Excuse the horn. We're actually built a new house and there's construction on, and that's the smoko lady driving around tooting the horn to get the tradies out for something to eat. I've got a IEC switch which will basically plug into the power supply, or use that for the power supply. So when I have the chassis or when I make the case for it, I can use this to plug the mains power into, and then have an on-off switch on the case, so I can turn the unit on and off instead of having to run back to the mains power and turning it on and off from the switch on the wall. The motors themselves, I'm looking to run on some. I went out and bought, it's not really interesting, but some shielded cable, 4-core shielded cable, because I've heard, after all the reading I've done on sites like cnczone.com and on the internet, they do talk about making sure you shield the wiring, especially using a plasma machine, because when you're arcing, it creates a lot of interference, and that can drop steps and send drop steps through to the motors and things. So I'll be looking to make sure that I earth everything, earth the table, earth the power supply, earth the plasma cutter, and to try and eliminate that as much as possible. But I got some shielded cable because I think I was reading somewhere that people reckon that's really important to have. The cable, I bought these. Let's see if you can see. There's like a 4 pin microphone. I can get it open. Like microphone adapter, male female adapter. So you got 4 pins for the 4 cables on the stepper motor. These again, these are for the case. I'm going to drill some holes, mount these on the outside, mount this piece to the outside of it, and then mount this piece to the cable. So all I have to do is plug them in like so and screw the cable up. It's more of a neat to make it look a little bit neater. So not really needed, you can just run the cables through the box, but I just purchased some of them yesterday, or purchased one of these to test it out. Other things you need, I went out and bought new soldering iron. I'm not the world's best solderer. I learned how to solder by watching YouTube videos, and it seems to be working so far. And other little things you need are software, the software to connect to your Arduino. We'll show you how to do that, and and installing Garble Shield onto this, and there's some other software packages that you need. All this is open source software, basically meaning it's a community that has developed this software and it's free. So if I do have to buy, if I do purchase something, I'll let you know the cost and that. So what we'll do is we'll go into sort of each component that I have here and we'll talk about it a little bit further. So first up is the Arduino Uno board, or this is they call it a replica. Basically, I bought it on eBay for $15. This is the brains of the unit. This is where you install a program called Garble, G-R-B-L, and that is basically that's the program that drives all your stepper motors and interprets the G code and sends out the pulses to turn the stepper motors and turn things on and off. I'm new to Arduino, never used it before until this project. Their website, which will show up here in a minute, is really easy to use. Downloading the software is really straightforward, and the information on the website is really easy to follow. It's a very small. I was actually, all the pictures I saw of these really didn't have anything to sort of judge the size of the electronics. So this is, I'm not sure if this is going to work, but this is a roll of, excuse me, leaning across, this is a roll of black electrical tape. I'll sit it on top of the board, and that's how big the board is. It's actually really small. So that was, yeah, quite, when I looked at it I'm thinking, oh, did I order the right thing? But yeah, small, very small board for doing what I want, hopefully. Down the track we might upgrade the electronics and I might use this for something. I've got a mill in the shed that I might look at converting to CNC later on. But at the moment, I thought, as I said, I wanted to keep a cheap DIY CNC machine. Let's see how we go using this. Okay, next piece of equipment I've got is a CNC Shield. CNC Shield, this is version 3. This was, I'm not sure who, I believe it was designed by a company in New Zealand, Protoneer. I could be totally wrong. I bought this one off eBay. It's with my plasma, with the plans, I need to drive 4 stepper motors. Garble Shield, I looked at, which is another shield that connects onto the Arduino. Basically a shield, my understanding is that a shield that clicks onto the Arduino just expands the board so you can add additional circuitry and so forth to it. Basically it expands the Arduino board. This one has 4, if we can see, has 4 basically connections to drive your 4 stepper motors. Each of this one here looks a little bit different, and that's because I've pulled the stepper driver off, but the board itself doesn't come with stepper drivers. The board has, as I said, it will drive 4 axes. So we have, what do we got here? Z, X, Y, and A. A can either be driven by itself, so you can drive 4 motors, or you can clone it to any one of the other axes. The way I've got it set up, with the jumpers just here, 2 jumpers, one here and one there, is to clone the Y axis here. The reason I'm doing that is the plan said that to drive the Y axis, it's probably best to have 2 motors, so that way the gantry won't crab, I think they call it, so it won't bind up on the track. So if you've got, because it's the widest axis and there's 2 sets of tracks it has to run on, if you drive it from each side, you'll get better linear motion than you will driving it from one side. Or so I've read. We'll find out. The board also has these pins here, I believe, are for external steppers. So if you don't want to use these drivers, you can connect external step drivers to it. I'm not really sure. I guess that would be for those, those bundles you find on eBay and so forth, where you buy the stepper motor and you buy the driver, and the driver's like a big box type thing. Then you connect them here. They've got the axis and the direction. Next, we have all the axes on this side here. If you can see, we have, starting from the bottom, E-stop, so emergency stop, resume, so you can hold the program, which is the next one up, and then you can resume it. Abort will abort the program. You have, coolant enabled, spindle direction, spindle enabled, and then these pins here where my finger is, up the top here, these are your limit pins. They're interesting. Basically what you do, or what they do is, you have little switches, little momentary switches, that once it's depressed, it will actually halt the machine. So you put them on the end of your axis. So you put it on the end of the x-axis, end of the y-axis and z-axis, so that if the program tries to push the motor or tries to push the gantry outside its work area or outside the physical limitations of the table, it'll trigger the limit stop and it stops the machine. So it's basically so you don't crush the gantry off the end of the table or damage your stepper motors. So yeah, really, really cool. And then it's got some other pins up here for 5 volt and 3.5 volt discharge. But I'll put links to protoneer.co.nz about the CNC Shield version 3, and you can have a read up on there. It's really, really good information. They don't worry about it. The instructions that they have on there is how to actually solder on each of the components and that. I bought this. I'll put a link to the one I bought on eBay. But if you just search for CNC Shield on eBay, you'll find the pre-assembled ones, and this was like $8. Okay, so this is the, I think they pronounce it Pololu stepper drivers. It's basically what basically controls the actual stepper motors. Now the CNC Shield, I forgot to mention, it supports up to 36 volts. I've got a 24 volt power supply, but this will run up to 36 volts, and basically doesn't mean that some of these Pololu, however it's pronounced, stepper drivers, it's P-O-L-O-L-U stepper drivers, can run that high at 36 volts. Apparently there's an A4988 driver. They're not designed to run at 36 volts, but you basically blow them up, so they say, or so I've heard. But these ones, the ones I got it's a Pololu DRV 8825, which are these ones here, and they will run up to 36 volts. I thought just better to be safe than sorry to grab these. I got 5 of these for like $7, I think it was, off eBay. Again, I'll put links to all these components in the info below. So these little units just they also come with this little heat sink. If you're going to run it at its max amperage, which is 2.5 amps, then they say to put the heat sink on. And I can tell you from testing, these do get quite hot, and you wouldn't want to have a heat sink. You wouldn't want to not put the heat sink on, because it will actually fry the chip out. They're easy to put on. There's a little sticky adhesive that just peels off, and all you do is just stick it onto the chip itself. And these simply click in like, I'll move my hand so you can see the pins. Now the pins on these I found interesting to try and make sure I got them in the right way. I had a look on the back, and on the back here, we'll see if we can get you in focus, if it'll focus on here. No, let's switch to manual focus and try and get you focused in this way. Might have to come back a bit. Okay, just here we go. It's got some, it's got the pins marked on the board. Now what I did is I flipped the CNC Shield over, and I found, when I was looking on here, or maybe it was in here. Again, folks, this is going to be, as I said, this is going to be as raw as it is. I'm a total novice to this. Yeah, I found EN here, which I think is enable, I believe, on there. So right up in the side here, there was marking EN, and I looked at the bottom of this and I found EN marked on here, and basically just line the pins up. Move my hand out of the way so you can see, and it just pushes in like so. So you just put the 4 of them in now, and away we go. Now it took me a while to, I don't know why, but it took me a while to figure out where you connected the stepper drivers to. I was looking everywhere, and for the life of me I couldn't find them, and I ended up finding them. But it's in here. There's a set of 4 pins. 1, 2, 3, 4. Set of 4 pins here, 4 pins here, 4 pins here, and they correspond to the 4 wires on my stepper motors that I've got. Other things on the board, you got a reset button up the top here, which you can see here, and this is your voltage in that comes from your power supply, and it will run from 12 to 36 volts, and as I said, I've got a 24 volt power supply, so that's within the range, so that's good. That's pretty much all about the CNC board. And the CNC board, good thing I found with this is on the, excuse my hands, is on the cutout here, lines up with the cutout on the Arduino. Now I also looked at the pins, because on the back of this board it actually has spindle enable, and the pins just line up like so. Now there's some pins missing here which you can add to if you need, but there's no need for it that I've found, and the pins all line up on this side, and then this is simply a case of seating it, and we're done. So that is basically the brains of my CNC plasma machine. Okay, so the next thing we'll have a look at is the stepper motor itself. As I said earlier, these are 425 inches of torque on the motor. The plans recommend a minimum of 270 inches. These run at 2.8 amps because the little polar loo drivers only run at 2.5 amps max current. It'll just reduce the torque of these down to about, I think it's about 10% I worked out. So, but it's still above the 270 minimum. I've got 4 of these. I bought these from Oz CNC here in Australia. Just a little touch over $200 delivered. The cable, these don't come pre-installed. I've installed these. These are just little, I don't even know what the name of these little clip things are. I just went to local electronics store, J-Car, and said I need this to fit on this board, and he gave me these and said you can just crimp them on or solder them on. So as I said, I'm not the world's best solderer, but I managed to get them all soldered on. And to figure out what you do when you get your motor is you need to figure out what coil, because this is a bipolar motor, stepper motor, and it has two, the way I understand it, I believe it has 2 coils that make the motor spin around and so forth. Again, folks, as I said, I'm a novice in all this, but from what I read, you need to make sure that each coil, you find the pairs. So there's a positive and a negative for each coil. Now, on Oz CNC, they have a wiring diagram that tells you what wire is for what coil. So my black wire, now these may be different depending on what stepper motor you get, but the black wire is for the first coil, or the A, they call it an A and a B. This is A positive, and the green is A negative. And then we move to coil number 2, or the B coil, and the red is the positive and the blue is your negative. Now, a trick I learnt after watching one of John Saunders' videos on NYC CNC was to find, if you don't have a wiring diagram that comes with them, then if you turn the motor, I'll turn it this way, you can feel resistance in it. Now, if you short out the corresponding wires to a coil, this becomes really difficult to turn. So if it's shorted out and it's really hard to turn, then you can almost sort of guarantee that these 2 wires are a pair. If you use, and then you'll find you do with the other 2, if you find that they short out and it's hard to turn, then there's your next pair. And what I did is, just so I knew what pair was what, is I just sort of tied 2 little loops through them. Now what I plan on doing, at the moment I'm testing these, so I've got them cabled up like this, but I'll probably, in the end, I'll end up cutting these wires probably further down around here somewhere where the loops are, and these wires will be joined, because this plug connects onto the 4 pins of the CNC Shield, and when I cut them, this is that female adapter. It's got marked on the back pin 1, 2, 3, 4. I'll just wire these up so that they correspond to the wiring of the male that'll run down into the stepper motor, and what I'll do is I'll just solder the wires together and shield them off and heat shrink them so that it's nice and neat. And this one has actually got a spindle out the back as well, so it's I think they call it a dual spindle. You can get them just without this one, but all I'm going to do is on the back here, there's 4 little holes, 1, 2, 3, 4. I'm just going to make a cover that sits over the back, so it'll just cup over the back of it like that and screw in, and that way it's not going to get dirt and dust in through the spindle hole, and it'll keep the spindle covered. And you've got your holes up here for mounting to your motor mounts. Now these are NEMA 24s. Apparently they're almost identical to NEMA 23s, except they're a little bit longer in the back here. So that's pretty much the stepper motors. Okay, so next up here is the power supply that will drive the shield. It will run into the negative and positive terminals here on the shield here, on the little blue connector. Now it's a 24 volt 15 amp power supply, and this one has an AC input of 110 or 220 volts. Here in Australia we run 220 volts, so it has a simple switch on the side here that, if you can see in there, you can flick it to 110 or 220 like most PC power supplies. Make sure, if you're in Australia, make sure, or wherever you are, make sure it's on the designated voltage for your country, because if I know from experience, if you plug a 110 power supply into 240 volts, you hear a snap, crackle, pop and smell smoke. It basically blows the power supply. This one has a automatic fan cooling. It turns on if it needs to. It also has the first, they're all numbered on the top here. The first three, 1, 2, 3, are positive voltage terminals. 4, 5, 6 are negative voltage terminals. So that's on the DC side. On the AC side, so basically what you plug into your wall, you have 3 connectors, 7, 8, 9, and that's earth, neutral and live for this power supply. Again, I bought it on eBay. It was about 30 bucks, I think, delivered, and it doesn't come with any of the wiring, so I had to go out and buy a little piggy tail, whatever it's, power cords I can plug into the wall with the standard wall plug for here in Oz, 3-pin plug, and just basically wired it in. And then I've got 15 amp automotive wire that I used I think on my ute to wire up some lights, and I have it in black and red, which I have connected into the voltage side on 1, voltage side on 2, and these are what come down. Just get so you can sort of see this. So this board goes like that. Get myself a screwdriver, and we will twist these out. Now when you're working with electronics, for people that haven't done too much of it, it's a good idea to make sure you ground yourself before you touch electronic components, because so you can see this, because if you've run a static shock through your components, you can actually basically blow things up, damage the boards. So it's always sort of a good idea. I tend to lean an arm on the desk before touching it, so if I do have any static shock, best not to work on carpet. Here I'm working on a timber floor, timber desk, so the chances of static electricity are sort of minimal. And then we just pop this one in here, and we'll just close this like so. Now, excuse the camera work too. This is sort of as I said, I'm sort of new to everything, filming for YouTube, building this CNC, so hopefully as the videos go along, the videography gets better too. So that's all wired in, and most importantly, just double check that you've put your positive to your positive terminal and your negative to your negative terminal. If you swap them around, it'll blow the board, definitely blow the board, and then you'll basically, and it may damage the shield. It'll definitely damage the shield, and it may even damage your Arduino. So please double check it before you turn anything on. On the power supply here, there's a little, I think they call it a potentiometer, but this thing here, you turn that to change what voltage you want. So at the moment it's sitting on 24 volts. And again, this little board here will take anywhere from 12 to 36. So I'm sitting on 24 volts. So what we'll do is, let's turn it on. I'm just going to plug it in and we'll see if we get any lights or if we get smoke. Hopefully we don't get smoke. Okay, so power supply's on. So I've got to be careful now because we're running live 240 volts into here, 24 volts out. So my power supply LED's on. Now to the board itself, what we'll do is, let's see what voltage we're getting. There's my little multimeter. Folks, grab a multimeter. I'm just going to duck off and grab it, and I'll be back. But yeah, when you're doing this sort of stuff, just a cheap multimeter is an absolute godsend. Just bear with me while I get the multimeter. So my multimeter is just a cheap Dick Smith one. I think it was like 10 or $12 or something like that. So we've got it on, and I'll set it up here so we can have a look. And let's see what voltage we're getting across. Well, that's higher. Have I got it on the right setting? 1 second. So we'll touch these on, and we get 24.3 volts. So we know we've got the right current and the right settings on our power supply. Okay, so we talked earlier about the stepper motors and wiring up and so forth. A little handy thing, these, I'm not sure if you can see them, these are the little pins. Try to focus on those if we can. They're the little pins, there's 2 of them there, 1, 2, that you have to solder your wires onto. Now, what an absolute, I was looking at it going, what will I do? So what I came up with, and people will probably laugh, but I used, let's move the board out of the way. Now, just so you know, I've turned the power off to the power supply. So there's no power running through this. Oh, and whenever you connect anything to your CNC board, make sure it's turned off and allow some time for the power supply to discharge. Just wait 10-15 seconds for it to discharge before you start plugging things into your shield. So back to these little pins. I'm thinking to myself, what am I going to do? How am I going to solder these onto these wires? I'm just trying to work them out. As you can see, I drop them. Now that's how sort of fiddly they are. So I found this, which is a leftover from when we were doing our wedding planning like 4 or 5 years ago, before we got married, my wife and I. And it holds these little pins. Now, I thought, wow, that is brilliant, because now I can literally, I don't have a wire, but a free wire, but I can lay the wire on here with one hand. And what I was trying to do, what I did is I literally made the wire sit down in here, and then I was able to get my soldering iron and the solder and able to solder a little strip onto it, so that they so this is handy. And this is just sitting on this lid is like from a baby formula tin that we'd finished, and I just used some blue tack to stick it down. So yeah, so that's basically how you click them on, and then they just clip, they just slide in to the holes here, and then they just pin down onto your board. So yeah, so I just thought I'd show you that as a little snippet, little tip that I found. So let's move on and install the software onto our Arduino so that we can talk to our stepper motors, and let's have some let's try and make the stepper motors work. Well, if you stuck through the long first video, I do thank you very much for hanging around. The next videos, or the videos moving forward, I'm going to try and keep to about 10 minutes, 25 minutes maximum, depending on what we're doing. But the next one I plan to shoot is everything connected up and running. I've got some limit switches, came in the mail today, so I need to get those connected. I've also got a bag of, I've got 3 switches which are red, yellow and green, which I'm going to use for abort, resume and hold. I need to get a emergency stop switch sent through, but we'll look at that, purchasing something like that later on. So the next video is basically going to connect up the stepper motors and sending a G-code, or sending a file via universal G-code sender for Garble. I'm going to send it through and see if we can get the stepper motors to turn and jog some motors and basically get them to move. So moving forward, as I said, 10 minutes to 25 minutes max on a video, and please leave comments if I've muffed something up or there's a better way of doing something. I'm more than happy to hear about it. Again, thank you for watching, and hopefully we'll get some new videos out shortly. Until then, thanks. Cheers.